Oh, yeah.
So what is it?
Trinomial.
Perfect. Descending order?
Yes.
Mm,
Careful.
no.
Very good. So I have to rearrange it. I have no choice. X squared minus x minus 20. Greatest common factor?
There's none.
None. Negative leading coefficient?
No.
No. Special product? Here's how I know it's not. Because both special products have to have plus as the last term. Not possible. Good. So the answer is no. So here is again. Trinomial, descending order, no. I had to rearrange it. Greatest common factor, no. Negative leading coefficient, no. Special product, no. One is a leading coefficient, yes. So I'm in item 6. Nothing else works right now. So how do I address this issue? I'm looking for two numbers whose product is negative 20. How come? Wait. Why? Why product negative 20? So remember when we got this negative 2 times negative 2, we multiplied to get this number. So that's why I'm looking for two numbers whose product is negative 20. Same numbers, when I add them, I get negative 1. Wait, how come? Where does that come from? Same thing from before, right? When we added those two, we added an AB and an AB. So we got, that's how this is the sum and this number is the product. So, product and sum. Can anyone come up with two numbers? Of course, because the product is negative, of course I want a positive and a negative. There is no other way. Can anyone come up with two numbers, a positive and a negative, whose product both have to be fulfilled, whose product is negative 20 and whose sum is negative 1?
Positive 4 and 5.
So positive 4 and 5. When I multiply them, I get negative 20, yes. When I add them, do I get negative 1? Yes. I'm done. So the answer is x plus 4, x minus 5. X plus 4, x minus 5. So this is not that difficult, I would say. Let's try another example. So let's say x squared plus 13 plus 36. $13x. So now you can say, wait a minute, show me. Okay, here it is. X times x squared, yes. Negative 5x plus 4x, negative 1. X. Positive 4 times negative 5, negative 20. It takes a blink to check. Till you get used to these things, I would always check. Always. Okay. I go through my steps. I cannot skip any. What is it?
I know me. No.
Descending order?
Yes.
Greatest common factor?
Yes. No.
Negative leading coefficient?
No.
Special product? Yes. Yes, it's a special product. Yes. X plus 6 squared. But what about the middle term? I rushed and I said, oh, yeah, perfect. X squared is x squared. 6 squared is 36. Yes, I'm done. No. What is the middle term here? 2 times the first times the second. Two times the first times the second. What is the middle term here?
12x.
12x.
If this is the same here, I'll say yes. If it's not the same here, I'll say absolutely not.
Absolutely not.
Absolutely not. So I go back to my drawing board. In that case, I will say I'm looking for two numbers whose product is 36, always the last number in descending order, of course, and whose sum is 13. This is the sum, this is the product. We need to find two numbers, both positive. How do I know? They have to have the same sign, and when I add them, they have to be 13. So they have to be both positive. I need two numbers whose product is 36, and at the same time, whose sum is 13. Both conditions have to be fulfilled.
4 and 9. 4 and 9.
I'm done. X plus 4, x plus 9. Check, a blink. X times x, x squared. 9x plus 4x, 13x. 4 times 9, 36. No one can come up with another. Even if you write it the other way, it's the same thing. X plus 9 times x plus 4. Now, do you understand how we check the middle term for the special product? You only need to remember 2 times the first times the second. 2 times 6 is 12. 12 times x is 12x. It didn't work because this was 13x. These are not identical, but these are. I factored. And now you can say, why do you need to know how to factor? This has many applications, this one doesn't. With this one, we can solve equations and so on and so forth. With this one, we cannot. So we need to know how to factor for what follows next. Okay, so I like to finish this with the last one, in which the leading coefficient is not 1. There is an extra step here. Okay, so I like to start with 6y squared minus y minus 1. 6y squared minus y minus 1. Okay. Again, the whole protocol. What is it?
Trinomial.
Descending order.
Yes.
Greatest common factor.
No greater.
No. Negative leading coefficient. No. Special product?
No.
No. 1 is a leading coefficient? No. So my only chance is the last one, item 7. That's my last chance. Here is the extra step by comparison to the previous one. The sum of those numbers is the same. That does not change. But the product has to be calculated differently. That's the only difference. This is the product. Here, there was no point because there is 1. So there is 1 here, so the product is still negative 20. But here, when the leading coefficient is not 1, the product becomes 6 times negative 1. Because the leading coefficient is not 1. Okay, I need two numbers. Obviously, one has to be positive and one has to be negative because when I multiply them, I get negative 6. And when I add them, I have to get negative 1. So I need two numbers whose product is negative 6 and whose sum is negative 1.
2 and 3.
So which one is negative?
The
Yes, very good. Is the product negative 6x? Is the sum negative 1? Yes. But now here's what happens. I rewrite the polynomial. I copy the first term, which does not change. But the second term has to be copied using the numbers I determined. You determined, actually. plus 2y minus 3y, and the last one is copied. Don't go back and combine them. We worked hard to determine these numbers. Don't go back and combine them. It will be going backwards. This is still the same term. There is no change. This is still negative y, but it's written as 2y minus 3y instead of negative y. Why? It's because now we're going to factor by grouping. Factor by grouping. Which is easy. From this moment on, not difficult. Once I have those four terms. So, as you know my style. Okay. Disregard the last two terms for a moment and tell me what will you factor out from these two terms.
2y.
2y. Can you tell me what is left in parentheses?
3y plus 1.
Excellent. Careful now. I don't even want to look there because I may make a mistake. From the other two terms, if I don't get the same factor out, I either made an error or I cannot continue. So now I will uncover it and look. What will you factor out from these two terms so that we get the same 3y plus 1 in parentheses? What will I factor out from these two terms to get 3y plus 1? Remember, I need a sign. Sorry, Brent, 1 second, and a factor. If I need a sign and I need a factor.
-1.
Exactly. Brilliant. Exactly. Let's check. We cannot continue before making sure that this is true. 2y times 3y, 6y squared. 2y times 1, positive 2y. Negative 1 times 3y, negative 3y. Negative 1 times 1, negative 1. Yes. At this point, I factor out the common factor, which is 3y plus 1. What is left in parentheses? What is left from the first group? What is left from the second group?
2y minus 1.
2y minus 1. Ah, yes, I know it's long. I know, but it's once you understand it, it's clear and you can apply it. Now you can say, show me. Oh, yes. Yes, I want to. I want to because it takes a blink. 3y times 2y. Yes. Positive 3y minus 2y, negative y. 1 times negative 1, negative 1. So when the leading coefficient is not 1, the product is this. I find the numbers. I have to rewrite the whole thing from 3 terms to 4 terms so I can factor by grouping. When I factor by grouping, I literally cover the last two to make sure I don't make an error. Whatever I get in parentheses from the first 2 terms, I must get in parentheses from the last 2 terms because otherwise I cannot continue. I have to make sure that I have a sign and a factor. I stop for a moment and I check. After I check, I say, okay, it's clear. And then I check again. Multiply in a blink to see that I have 6y squared minus y minus 1. Any questions? Now, in order for us to have everything, I have to tell you that after we discuss the binomial and the trinomial, this is the easiest, the absolute easiest. Why? Because only factoring by grouping works, and we already discussed it. So let's look at a polynomial. The strategy doesn't change. We have to go through the same steps. I'm not going to rewrite them. 1 through 4 are the same. And number 5 is factoring by grouping. No special product here. Sorry, I'm sorry. So what is it? Polynomial, descending order, greatest common factor, plus negative leading coefficient. No special product. Maybe just 4. So it's a polynomial. It's in descending order. There are 4. I made this into 1. Greatest common factor, this is G. Greatest common factor, negative leading coefficient. And the last one is factoring by grouping, and that's it. And this is the end of factoring, but I want to squeeze in one example. So let's say x cubed plus 2x squared minus x minus 2. Factoring polynomials, the easiest. Descending, it's a polynomial, it's in descending order. Yes. Greatest common factor to all 4? No. Negative leading coefficient? No. Factoring by grouping? Done. So what will you factor out from the first 2?
X squared.
Very good. Can anyone tell us what is left in parentheses?
It's 2.
X plus 2.
What do I have to have coming out of the last 2? Otherwise, I can't continue and something is wrong. If they are not the same, I can't continue.
So you have to put x plus 2 in the parentheses.
I have to, otherwise I will not be able to continue. So now let's see. Factor, sign and factor. I cannot fabricate it, it has to be there. But I have to write it first so I don't make an error.
-1.
Exactly. Good. What is the common factor of these 2 now? Now these 2 terms have a common factor, which is?
X plus 2.
What do I have in parentheses once these are out?
X squared minus 1.
And this can be factored. It's a binomial and we know how to factor it, and we're done. What is the factored form of x squared minus 1?
X plus 1, x minus 1.
Brilliant. Thank you.